So using hashes to securely store password data is a great way to go. However, hackers have one additional approach that they can use to figure out what our users' passwords are if they do steal our data. And so I want to explore that now and show us how we can pretty easily address that and make it much more difficult for hackers to utilize this vulnerability. So the vulnerability is that the number of good hash functions in use is relatively small. So we looked at hashlib, and there was a handful of functions there. There's some other functions, including some good ones called bcrypt and scrypt that we'll provide links to on the course page. But there aren't hundreds and hundreds and hundreds and thousands of different hash functions that people use. So that means that if a hacker steals your data and guesses which hash function you used, they can still figure out user passwords using what's called a rainbow table. And so a rainbow table, basically, you can think of it like this. Think of, a hacker taking a bunch of common words and common passwords and then creating hashes of all of those, similar to this kind of small sample like this is here, and taking those hashes and then comparing them against yours. Since collisions are very rare with good hash functions, if, say, a hacker stole your data and guessed that you were using the MD5 hash function and then found a user that had this same hash stored in the database, they would then know that that user used the password 123456, right? And, they would not be able to sort of reverse engineer every single password in the database, but if people used poor passwords and common passwords like they often do, these are some of, frequently used passwords, unfortunately, the hackers would then be able to get into those users' accounts. The solution to this is to use what's called a salt. So for each password that we hash, we can tack on a random salt. And a salt is just going to be a string of random characters that we add onto the password to make it much harder to use this brute force approach. And so here's the rough idea. In some Flask-like code, we get the password from the user when they go to register, and then we create a salt, and that's going to be a random string of characters, and then we hash the result of concatenating the password and the salt. Okay, and so that's going to add an additional layer of complexity and randomness to the hashes to make it much more difficult for hackers to do this kind of thing. Okay, so let's look at how we can implement salts within our hashing code. Okay, so I'm here in my hashutils.py file, and what I want to do is implement salts within our hashing code. So I'm going to come up here, and I first need to make a function that generates salts. So let me define make salt, and this will generate a random string of characters. So I'm going to need a couple of modules to do this. Let me import random and import string. And then we'll come down in here, and I'm just going to type this code out real quick, and then I'll explain what it's doing piece by piece. Okay, so let's look at this make salt function. And kind of several things going on in this one line, but we can understand each of them in turn. This component right here, random.choice, and I give it the constant string.ASCII letters from the string module. The ASCII letters, that constant represents a string that contains all of the ASCII letters. And so saying random.choice will randomly choose one of those letters. And then I do that within a list comprehension. And so this will repeat 5 times. I will get a list with 5 random letters in it, and then I join that using .join, and using the empty string .join, we'll just put those letters in next to each other. Okay, so let's go ahead and test this out in a Python shell first. So I'm going to say from hashutils import make salt. Okay, so each time we do this, we get a random string of letters. Okay, so we'll be able to use this within our code, within our hashing code. Okay, so we want to use this at the point where we make the hash. Okay, so we said before that we want to basically, instead of hashing just the password, hash the password plus the salt. So let's go ahead and get a salt. And then I can add the salt to the string right there. And then now this is not quite what we want to do, because we need to keep track of the salt in order to basically reconstruct this process when we're verifying a password. So let's do it this way. Let's make the password and put it into a hash. And then instead of returning just the hash, I want to return both the hash and the salt and have that be stored in the PW hash column of the database. So I'm going to say, I'm going to make a string.format here. I'm going to put 2 placeholders in place and say .format. And those are separated by a comma. Notice that. .format. And I'm going to give this the hash and the salt. And so basically what I'll be doing is make PW hash will return a string that has in the first slot the actual hash, and in the second slot the salt that was used to generate that hash, because we'll need both of those components in order to reconstruct the hash when we're verifying it. Okay, so that is what will be stored in the database. When we go to check the password hash, we will want to verify that that what we get by hashing the password is equal to the hash that was passed in. And to do this, we're actually going to need to be able to optionally pass in a salt to the makePWHash function. So this works the first time we make a password hash, right? On subsequent occurrences, we want to use the hash that's already part of the string, right? So let's optionally let the user provide a salt. And so then I'm going to say if not salt, then I'm going to need to make one. If the user provides a salt, I'll use the one they give me. If they don't give me one, I'll use a random one, a new salt. And so now down here, I want to get the salt from the hash string that's passed in. So I want to say salt equals hash. And the way I get this out, since we know that the format of this string is going to be the hash, comma, and then the salt, I can split on a comma and then take the thing in the second slot. That will be this component right here, which we know is the salt. So that's going to be the salt from the hash that's passed in. Remember, this will be the value of what's stored in the PW hash column of the database. Okay, and then I can pass in the salt here, and I can check to see if that matches what was passed in. Okay, and that should work as advertised. Let's go start up our application and test it out. There are no database changes here, so I don't need to recreate my tables. I'm just going to go to my app, and I'm going to log out and create a new user because the user I created previously was using this old hashing stuff. So this user is basically dead. Actually, let me just go ahead and delete him from the database. And I can then use that same email to register again. Okay, so I want to register, and let me make the same user account. Okay, so that did log in. Let's check the database and see what our data looks like. Okay, and we can see this. We can't see the whole thing, but there we go. If we double click on it, you can see the whole thing. I have this long thing up front, which is the hash, then a comma, and then the salt. Since the hash and the salt both consist of just letters and numbers, no commas or punctuation there, I know that when I see a comma, that's the delimiter between those two. Okay, so that did create the new salted hash correctly. Let's go ahead and log out and make sure we can log in with that salted hash. And there we go. So we're logged in. So that all works as advertised. Just a side note, I want to point one more thing out before we leave this lesson. If I come and look at the network tab in my developer tools, I can look at the cookies that are part of this request. And before when we talked about cookies, I said that we'll kind of understand at some point what's going on here with these cookies. Let me show you a little bit more explicitly what is going on. So we talked about how the first portion of this was the portion I could decode and get the user data associated with my session. That was basically the email. The rest of this is going to be basically a hash and a salt in the same sense that we have in our database now with users, that we have a hash and a salt in that column that we can use to verify the user's password. The same thing is true of this string. The rest of this stuff is going to be basically the same kind of, fulfill the same purpose in terms of having a salt and a hash, so that that Flask can determine that we haven't changed the cookie. If the user changes the cookie, that will change the first part of the string just a little bit, And that means that when it's rehashed and verified against the hash and the salt in the second part, it will not match, and Flask will know that we've mucked with the cookie. So that's how the cookies are signed within Flask, and this is an approach used in site variations across most websites. All right. So that's how we can add salting to our data security to securely store passwords and make it difficult for hackers to steal our users' passwords.